Hey, statistics. So second part of this first section of section 11.2, chi-square test of homogeneity. We're going to put it all together, and so we kind of just did this. We're going to put it all together in a problem. Suppose the conditions are met to perform a test of the null hypothesis is that there's no difference in the distribution of categorical variable for several populations or treatments, 2 or more. Compute the chi-square test statistic by doing observed minus expected squared over expected, and then the sum is over all the cells of the two-way table. The p-value is the area to the right of the chi-square under the chi-square density curve with degrees of freedom. And so then this is the big one that was missing before. The degrees of freedom is the number of rows minus 1 times the number of columns minus 1. So example problem, go through the whole thing here. The Pew Research Center conducts surveys about a variety of topics in many different countries. In one survey, it wanted to investigate how residents of different countries feel about the importance of speaking the national language. Separate random samples of residents of Australia and the United Kingdom and the United States were asked many questions, including the following. Some people say that the following things are important for being truly, enter the survey country nationally. Others say they are not important. How important do you think it is to be able to speak English? The two-way table summarizes the responses in the question to this question. Do these data provide convincing evidence at the alpha level 0.05 that the distributions of opinion about speaking English differ from residents of Australia, the United Kingdom, and the United States? So we got sample from Australia, sample from the United Kingdom, sample from the United States. Is it different? The proportion that think it's very important, somewhat important, so on and so forth. So even if this distribution is the same as that distribution, same as that distribution. So that's the problem that we get set up. We're going to go ahead and do a full significance test at the 5% level. So our null hypothesis, you can just write out in words, is that they are, the null hypothesis kind of matches the name of the test. They are homogeneous. They are the same. There is no difference in the true distribution of opinion about speaking English for residents of Australia, the UK, and the US. And our alternative hypothesis is there is a difference. They are not homogeneous. There is a difference in the true distribution of opinion about speaking English for residents of the Australia, the UK, and the US. We will use an alpha level of 0.05. So that's our state step. Our plan step. So we want to check we want to say our name. This is our chi-square test of homogeneity, and check our conditions. So random, we have independent random samples of residents of the 3 countries. The 10% condition, we definitely got less than 10% of each of those countries. So 1,000 is less than 10% of all Australians, 1,640 is less than 10% of all UK residents, and 1,003 is less than 10% of all US residents. And then the large counts, we actually have to show our expected counts are all at least 5, and so we're going to perform that. We can do row total times column total divided by table total. You should be able to do that. So our expected Australians, I would say very important. Overall, is 2,569 out of that. That's our proportion times 1,000 would give us our expected for this. And so we could also use our calculator to help with this. There are our expected counts if we did row totals times column total divided by table total. Then we can get our do step. We can do our chi-square test statistic. We probably don't want to do all 12 of these because it gets super long, but you should be able to do the first couple. 690 minus 741 squared divided by 741 plus 1177 minus 1083 squared divided by 1083.1, and so on. And you get a chi-square test statistic that looks like that. And then you can do chi-square CDF. The degrees of freedom is rows minus 1 times columns minus 1. We have 4 rows of data, 3 columns. So it's 3 times 2, which is 6 for our degrees of freedom. And our p-value, if we do chi-square CDF from 68.57 up to infinity with 6 degrees of freedom, is approximately 0. That's a very, very large chi-square value. Our p-value ends up being less than 0.0005. If we look at our table, it's just a very tiny value. And then we'll show that in the calculator here. Because the p-value of approximately 0 is less than alpha 0.05, we reject the null hypothesis. There is convincing evidence that there is a difference in the true distributions of opinion about speaking English for residents of Australia, the UK, and the United States. So we did see a significant difference. Where is that difference? We'll come back to that. Many students lose credit on the AP Statistics exam because they don't write down and label the expected counts in their response. It isn't enough to claim that all the expected counts are at least 5. You must provide clear evidence. All right, so let's go back and look at this in the calculator and maybe even do a little more analysis of where that difference is. Let me pull up the calculator. The first thing that we want to do is we want to get this data into our calculator. So I'm going to go into Matrix, Edit, and we have you might be confused about the dimensions of this matrix. So it is always rows then columns. So there are 4 rows and 3 columns, and that gets my dimensions set properly. If you forget and you get it backwards, well, it's just going to make the wrong size matrix, and you're going to realize, wait, it doesn't fit. So then just swap the dimensions and get it right. But this is a 4x3 matrix, and so then I'm going to go through and type in those values that we saw in this table. So I'm going to type in those values right there. So we had 690, 1177, 702, and then 250, 242, 221, 40, 28, 50, and 20, 13, 30. Hopefully I typed it in right. This is a good argument for showing some work. So then you can go in and do stat tests chi-square test. And I have my observed in A. It's going to store my expected in B. And so I get that. So remember, it said something about our p-value being close to 0. That looks close to 0, approximately 0. 8 times 10 to the negative 13th. Got the degrees of freedom. We can check that. 68.57. Does that match their value? So if we go back over here, 68.57 does match their chi-square value. And then the other thing I can look for is, the expected. Does my table B match their expected? And so if I look in here, I can look at matrix. I like to go through edit and see it looks a little better. And so I see those numbers, and looking at those should match what we see here. And so that is doing it in the calculator helps speed that along.